Okay, in this podcast, we're going to cover a few topics. Primarily, we're going to talk about significant figures and we'll cover what significant figures are and why we use them and when we use them throughout the course. Okay, before we can talk about significant figures, though, we need to talk about what we refer to as accuracy and precision. A lot of people mix up the two terms. They think they're basically the same thing, but in science they have individual meanings. So first of all, you've got to understand that when we're talking about accuracy and precision, we're usually talking about data collected in an experiment or a hypothetical experiment. So we're talking about data that has been measured and collected by doing an experiment. Okay, accuracy means, did you get the right answer? Precision means, is your data reproducible? Or in other words, are you getting close to the same value each time you do an experiment? So if you're looking at the visuals here, we've got three different scenarios. First of all, we've got this scenario. Our data points, or the darts in this example, are all centered basically around the same spot. So this data is precise. It's not accurate because it didn't hit the bullseye, but it's precise because all the data points are around a certain spot. Here you can see that not only are the darts or the data points precise, but they're also accurate. In other words, they hit the right spot. And here what you can see is that the data points are not close to each other, so they're not precise, and they're also not around the bullseye, so they're not accurate either. So precise but not accurate, accurate and precise, neither accurate nor precise. Okay, obviously we're not going to talk about darts this year. We are going to talk about numbers. So what we want to do is determine our data points precise or accurate. So for example, let's say you're doing an experiment where you are measuring the boiling point of water. Water boils at 100 degrees Celsius at normal atmospheric pressure. We know that. So that's the value that we're looking for. Well, let's say you do 3 experiments. In the first experiment you measure the boiling point and you get a value of 112. Then you do it again and you get a value of 110, and in the third experiment you got a value of 113, and assuming these are all in degrees Celsius. As you can see, these data points are relatively close to one another, so we would say that they're precise. But they're not really close to 100 degrees, so we would say that they're not accurate. So these 3 data points are precise, but they're not accurate. On the other hand, let's say you measured your water at the boiling point again with 3 different experiments. You got 101, 99, and 100. These data points are precise because they're all close to one another, and they're also accurate because they're close to the right value. So precise but not accurate, precise and accurate. Alright, so when we do precision with numbers, what we want to do is look at what we call the significant digits in a number. The significant digits in the number are going to tell us the precision of the number. It's important to understand that significant does not mean important. Significant means the values in the number that are based on the measuring device itself. So for example, let's say you're looking at this number here. This number, it's assumed that it came from some sort of measuring device that can measure to the 100th place. So it's pretty precise. On the other hand, here you've got something that is measuring to the ones place, so it's not as precise. And we'll, again, as the year goes on, what we'll do is talk about how many digits you have, the placement of those digits, and the precision. But the first thing we want to do is count how many significant digits are in a particular number. And there's going to be 3 different scenarios. we're going to have, or I should say 4 different scenarios, sorry. We have non-zero digits, 5, 4, 6, 5, 6, and then we have zeros. Zeros can be trapped. In other words, that 0 there is trapped between 2 non-zero digits. The other thing we have are leading zeros. Leading zeros are zeros that are to the left of a non-zero digit. And the other scenario is trailing zeros. Trailing zeros are kind of like the opposite of leading zeros. They're zeros that are to the right of any non-zero digit. So you've got all non-zero digits, trapped zeros, leading zeros, and trailing zeros. The rules are fairly simple. All non-zero digits are significant. So we would say that this number has 1, 2, 3, 4, 5 significant digits. Trapped zeros are also significant. So this number would have 1, 2, 3, 4 significant digits in the number 4,505. Leading zeros are never significant. So we don't count those digits, we only count the non-zeros, 1, 2, 3. So 0.000345 has 3 significant digits. Now these 3 zeros here are important. They tell you the placement of the number, but they're not called significant. In other words, the measuring device is not measuring in that region. It's measuring in that region. All right. Trailing zeros, there's 2 scenarios. Trailing zeros are only significant if a decimal point is actually written in the number. So we know that both of these numbers have the same numerical value, 500. But this one has the decimal point written there. Even though it's implied that there would be a decimal point there, it's not written. If you were to move on in science, we would address this further. But for now, what you need to understand is trailing zeros are significant if there's a decimal point physically written in the number. So that number would have 4 significant figures. 1, 2, 3, 4. That number would have 1 significant figure. Those 2 digits are not significant because there isn't a decimal point physically written in the problem. Alright, so let's just review quickly. Accuracy means, is your value correct? In other words, are your data points around the correct answer? Precision means, is your data reproducible? In other words, are your data points all around the same point? Not necessarily accurate, but precise. And then the other thing we talked about are significant digits. Significant does not mean important. They simply mean the digits that are represented from the measuring device. Non-zeros are significant. Trapped zeros are significant. Leading zeros are never significant. Trailing zeros are significant if a decimal point is physically written in the problem. The next vodcast, we're going to go over how you calculate using significant figures.